Hello, I'm Tom Abbott with Airfloat, and today I'm going to talk a little bit about our single bearing air skid system and how to use it. So when you purchase an air skid system, the first thing you'll need to do is unpack it. It'll come either in cardboard boxes, 1 or 2 skids per box, or on a skid banded down to a skid for larger systems. Your air skids themselves will look either like this steel air skid or like this cast aluminum version. They'll both function basically the same, but those two versions are what your skids should look like. In addition to either 4 or 6 air skids, you'll have a control package, and the control package basically is an on-off valve that will have your main air in connection that will be supplied by you. Typically it'll be a pipe connection that you'll match to your incoming airline supply. The first thing in the system will be the ball valve that turns air on and off to the air skid system. From there we go into a manifold that will divide that incoming air into each individual air skid. Those connections will go through a flow control valve, which will adjust the airflow to each individual air skid, and then through a quick disconnect into a hose assembly to make the connection to the air skid. Now you'll notice in all of our quick disconnects and in your incoming air supply that you're responsible for, we recommend a flow-through fitting, which is a free flow type fitting that has no internal air valve to shut it off, so you get very little flow restriction through that fitting. You can also make a hard plumbing connection to your incoming air supply if you don't want to use a quick disconnect. This particular version of control package is one that we typically use. We also have this version, which functions basically the same. It has the same air in, the same on-off ball valve. At that point we have a regulator and a gauge, but then it goes into the same manifold, flow controls, and quick disconnects. You'll notice these flow controls are a little different than the other style, but they operate the same. They just increase and decrease airflow to each air skid. Now at this point I think we're going to look at a typical setup arrangement, how to arrange the air skids, and then go on to a practical demonstration of how they operate. This is a typical arrangement of an air skid system, and basically what we have here are 4 single bearing air skids, a control package which has the on-off and manifold controls, and 4 hose assemblies that connect to each air skid. One important aspect of using this system will be the placement of the air skids. In this case, we have a steel framework that we fabricated just for demonstration purposes, and we've placed an air skid at each corner, which basically is in balance with the center of the load gravity. So our CG of the load is centered over the 4 air skids as best we can. One thing to keep in mind as you place the air skids is we need enough framework support that will keep that air skid parallel to the floor as it lifts. In other words, we don't want the air skid to tilt as it lifts. If we couldn't use a corner construction like this for support, and we had to use an individual piece of the structure, we would put the air skid basically centered as well as best we could, and then use some additional cribbing, either wood or metal, across 2 air skids to keep them parallel to the floor. After we've positioned the air skids, we'll make the air line connections, and typically we'd like to keep the individual air skid connections separated so that we're able to identify which flow control addresses which air skid. So in this case, we've got the air lines separated, and we'll know which air adjustment will control the air skid. And you can see as the camera moves around the setup that we've tried to keep the air lines up away from the floor and separated as we make the connection to the manifold. Our incoming air line has already been connected, and at this point all 4 hoses are connected, and the initial settings on the flow controls are set to approximately 1/4 on for each control. Okay, now we're ready to do a practical demonstration. We've got a test set up here with some test weight, and Josh is going to help us be a spotter for the system. We recommend having at least 1 spotter to make sure that the complete area is clear whenever you're moving. So we've got our air line connected to the controls. At this point, I'm going to adjust all the flow controls to the same position about 1/4 of the way on, and then I'm going to turn the main air on. And at any time that you either turn the air on or off, you need to announce that you're doing so for safety reasons, so everyone can stay clear of the equipment as it raises and lowers. Okay, Josh, I'm going to turn the air on. I'm going to turn it on about 1/4 of the way, let it come up, and then I'm going to look at the adjustment on each air skid so that we maintain the same floating height. And the way that you adjust that is with the flow controls. And if you look at this air skid, I'm going to shut the air off, and you can see that it lowers. If I turn the air adjustment back up, I can raise that height until it matches roughly the height of the other skids. So at that point, I would walk around, look at all 4 skids. They look good. At that point, I'm going to turn the air supply on further and find a spot where it is the freest floating motion. Looks like right there is about our optimum position for the air on. So at that point, you would go ahead and make your move. And we're going to assume that we're at the end of the move and we're in position. So Josh, I'm going to shut the air off now, and we'll come back down to rest on the framework. One important aspect of the use of an air skid system is the floor and the surface conditions of the floor. Here we have basically a raw concrete machine troweled surface that is a good air bearing surface. This would be an ideal surface to move across. You may have other situations in your particular application that have problem areas such as cracks. In this case, we've got a cracked area that's been repaired. The repair can be done with a flexible crack filler as long as the crack's not too bad. For a one-time move, you can also cover that crack with a tape. We recommend a smooth finish refrigeration tape that you'd clean the area, just apply the tape over the crack, and you'd be able to float across that tape at that point. For areas that are worse than a crack, such as an expansion joint or a saw cut or possibly a floor drain, you can use an overlay. In this case, we've got basically a pit cover, and to move across that pit cover, we can use a flexible overlay of sheet vinyl, or sheet metal works very well for this as well. So in using an overlay to move across that, the best way to do it is to place the overlay, then tape across the edge that you're going to be moving onto it, just to hold it in place as you move across. And that should cover most situations as long as they're level with the operating surface. For depressions or other conditions, you should probably consult the factory and get recommendations on your specific requirements.